Hello everyone, it's Mr. Barden here. Today we're going to go over how to create a frequency-based level meter. So what exactly does that mean? Well, if I just open up a new tab and type in that, well, that didn't actually pop up with things as useful as I thought it would be. I was thinking more of like the little cheap LED ones. Light spectrum meter. Not now. We'll just do audio, because that's probably where it got confused. There we go. That's what I was imagining would pop up. These kinds of things where it tells you the approximate volume of a specific frequency of sound. You'll notice as I'm going through the shopping page here on Amazon, these aren't always the cheapest things, and just looking at it, you might be able to tell these aren't always the best built things, but they can be kind of cool. Things like that. It's different than a VU meter, what we're going to do. But we're going to be building this as a P5 sketch, a web app, essentially. Right there, we'll just be doing it right in P5. It's really easy just to monitor the volume of a sound file. It's a little bit harder to break it up and say that specifically the low sounds are this level while the middle and highs are other things. That involves a few extra steps. So we're going to hop into that very shortly. But before that, I just wanted to give a shout out to a few other people who kind of gave me the idea for how to go about this. I'll have their links to their channels in the description below. But semi-recently, the channel TechMoan did a thing where he compared a whole lot of these different meters to see, do they work? Are they good or bad? How did he feel about them? So that kind of got the idea of these meters in my mind. And then another channel, the Coding Train, did a video several years back now. I think it was like 6 years ago, doing a very similar thing, but with a different coding library. So in the Coding Train, he goes about and uses the built-in P5 sound library, which is totally fine. It's all good, nothing wrong with it. For the course that I teach, we don't use that one. We use Tone.js. So that's what I'm going to be showing you how to do, because it's a little bit different in terms of what we need to include and how we type it out. Lastly, as kind of a bit of a FYI, the one that we're building will only be working with audio files. Because this is a browser-based thing, it becomes a little bit harder to get access to the microphone or another audio input in order to utilize it and have it respond in real time. If I can work out a good way to do that and also record it without any issues, I'll come up with a follow-up video. But let me know if y'all are interested in that in the comments down below. I'll put that more at the forefront if y'all actually want to see it. With that being said, let's get started and we'll determine the various frequency levels of a sound file. So the very first thing we need to do is include the Tone.js library. I've already got it in here, right there. I'm not going to break it down in excruciating detail right now how to do this, but basically we just need to include the HTML script that tells us to go find the library and use it. We have to paste it here into the HTML file and then remove the one that tells P5 to go look at P5 sound, because the tone and sound fight each other. I have tons of videos about that on my channel and in the textbook and all of that for this course that I teach. So I'm not going to break that down right now, but I will include in the description, along with links to the various other channels I mentioned and all of that. And if I remember, I'll put them in the cards as well. But a link to the textbook page, PDM, there we are. Right here, where you can just copy that particular HTML code. Or if you just wanted to pause the video and type in that URL, it'll take you to this spot and you can copy and paste that right into the code. Okay, so this sketch already has tone loaded, so we need to first load up the sound file that we want to use. This can be any sound file, so we're just going to use a random one that I pulled out of the textbook for this course. So we're going to say let, use background sound this time. So we're just going to go step by step. So in preload, again, we want to do this in preload because we have to load up the sound files before anything else happens. So preload background sound is a new tone.player. I'm using player because it's only one sound file. And now we just need to actually load in that file and tell it where to find it. I'm not going to put it in a folder because for the sake of this video, it's just one sound file. So I have it there. I'm calling this one loop1. I think it's an MP3 file. So I'm just going to go over here to upload file. I'm going to run way over here to my other monitor to drag in. There we are. Yeah, it is an MP3. All right, boom, it's loaded up. Loop1. And there we are. So this next bit, it's pretty straightforward. We have to make a few new things and connect them all together. So I'm going to call this one my FFT in all capitals. And I'm going to go down here and I'm going to type out and we're going to make it a thing. And then I'll explain what it is because this is completely new stuff. It's not even in the textbook yet. So my FFT is a new tone.fft. And we'll leave it blank for now. So an FFT stands for Fast Fourier Transform. And what this is, again, I'm not going to dive into a whole lot of the math and everything, but basically it is a relatively fast computation. That's why it's called the Fast Fourier Transform, made by a guy named Fourier, Fourier. Yeah, Fourier. Fourier. He's it's a very French sounding name. But basically, it just converts a sound from, we're measuring it in the amplitude, the volume range, and we convert it to looking at the frequency spectrum. What that actually means is we're going to get something like this, where we have a sound, and normally we would just look at the the air pressure amplitude over time, but by looking at it in the frequency, we can see the particular volumes of the sound bands making up the sound. So we can see that, oh, it's this, yes, it's this loud, but these sounds are what make up that, that volume over time. So that's what we're going for. We're going to be able to look at it and say, hey, these are the frequencies in here and they're at this level, as opposed to just the level. All right, so that's what the FFT is. And basically what it does is it takes the whole audio spectrum and breaks it up into what we call bins, or just little sections of audio. So it's got the whole frequency, and it breaks it up into little sections. And then for each section, we determine the level of that one individual section. And that's what's going on there. So we need to tell our FFT object as an argument how many sections, or bins is the appropriate term, to make in order to break up the full 20,000 hertz audio spectrum into different ones. There are a few rules here. They have to be done with in a power of 2, so they have to be a multiple of 2. You can't divide it into an even a number. The minimum is 16, and the maximum is, if I just head over to the tone docs, there we are, the tone documents, and pull up FFT right here. Boom. This is the object that we're using. We've got, there we are, the size. It's a value of 2 from the range of 16 to 16,384. This means that you can break up your sound file that you are analyzing into either 16 frequency bands or anywhere, as long as it's a multiple of 2, up to 16,384. Keep in mind, though, that the more you have, the more chunky it's going to be, because we have to process a whole lot more information. So You can use what you want. For the sake of it not looking totally cramped on the screen, I'm going to be picking something on the smaller end, but depending on what you need, you have a lot of headroom to work with. I'll also put a link to this down below. There's everything about the FFT that we might need. It's all just right here. So let's hop back over here. I'm going to start with just 128 bins. So when we're done with this, we'll see 128 different frequency areas, but you can tweak it to whatever you want. The next thing we need to do is just connect all of them. So we can just say background sound dot, I'll use chain, just so I can say we're going to send the sound file output into my FFT, and we'll take the output of that into tone.destination, just so we can hear the sound file playing back. So that's there. I want to be able to start and stop this with a button on the screen. So I'm going to add that real quick. So I'm just going to do that part in setup because we don't have to actually make new things. So I'm going to just hop up here. So I'll put the buttons up here. Let start button and stop button. So this is going to be pretty simple. Start but is a equals create button. It's going to say start but dot position. I'm going to put these at the top of the screen. So we'll say, I don't know, 25 and 25. Start, but a capital B there. Dot mouse pressed, and we'll say start sound. All right, so again, if you're unaware, when we make a button in P5, we take a variable and we assign it to be create button. That function will handle all the HTML stuff and make a button with whatever text you give it on the button. We can then give it a position with an XY and set up a callback function to run anytime we click the button. So I just have to go down here, make the callback. Function start sound. And this is just going to be very simple. BG sound dot start. Just like that. This is going to be almost identical to the stop button. So we're just going to do that. And we'll change this all to stop, stop, stop. And this last one is stop. We'll change it to, instead of 25, I'll make it, I don't know, 225. We'll adjust that later. And then this last one, we'll make it stop. Stop sound. And we'll just make an almost identical function. Only again, this is stopping the sound instead of playing it. So now, if we run this, we get the sketch. I made the background bright green, by the way. With these two buttons, one will start the sound, one will stop it. There we go. So that's the sound file I picked. I tried to get one that had a variety of frequencies in it, but anyways, that's the sound file right there. We can start and stop it. Now here comes the slightly harder part. In the sense of this is all new stuff now. We're working specifically with the FFT object. We have to get the values and then use the values. So to get them, we need to, well, talk to the object and store them somewhere. So I'm going to go up to my variables with the objects. I'm just going to call this levels, first, frequency levels. And we're going to actually make this an empty array to save some time. So whenever we get the values from the FFT, it comes back as a, I think it's a 32-bit floating point array. You can find it under FFT and get value. There it is, get value. Yeah, a floating 32 array. So you could use that to work with it however you want to, but we're going to do it very, very simply. So levels is going to equal my FFT dot get value, just like that. And that's all we need to do in order to get the values. I want this to update in real time as the sound file plays, so that's why it's happening in the draw function. If you only need it to happen at a certain instance in time, you could stick it with a button or in some other function and only call it when you need it. But for now, I just want this to happen, for as long as the sound file is playing. So from there, we can do a few other things. What I'm going to do is create a for loop. For let I start at 0. And we're going to run this for a specific duration, and it's going to be for the however long, not length, we need levels dot length is. And that should be I is less than. There we go. And then just so it's not I plus plus, so it stops yelling at me. So we're going to first, every draw function, we're going to get the levels, and then we're going to run a for loop, and we're going to do something for every level that we get. And this is where we're going to draw the various things inside of this for loop. So there's a handful of ways we could go about doing this. Really, at this point, it's almost up to your particular style and aesthetic. I'm going to show you one way to make it, but I would really love for anyone watching this video to try to, stylize their own display, to make their own version that that'll go, because mine, it works. It's not ugly to look at, but it's nothing special. I love seeing, people taking the basic concepts and making their own creative version of it. So let's do that. I'll show you what I'm gonna do, but I would love to see what you all do. If you put links to that down in the comments below, it'd be amazing. All right, so what we need to do is create basically a line in order to set up everything we need to do right here. So let's do that. Inside of my for loop, this is where we're going to pull some stuff up. So let's do it like this. Let's do push and pop, just like so, just so things don't fight each other. And then we can say do stroke weight. Let's make this kind of thicker at, one too many, at 10, and I forgot an R right there, stroke weight. We'll make these kind of thick lines. And then we're going to go in, and we need to actually make a line. There's different ways you could do this. We could store it as a thing. We could just make it. I like the idea of storing it as a variable, just in case. So I'll just make it a local variable so we don't have to monitor a bunch of stuff. So the bin mapped. So what this is, this will, that shouldn't be that, equal a thing. This will take all of the appropriate levels and map them so that what we're going to have is a line that comes from the bottom of the screen, and as the volume increases, the line height also increases, and then as we move from low frequencies to high frequencies from left to right. So to do that, we need to use the map function. I already had that there. And whenever we have the map function, we just need to say what the level, what value we're mapping. So we're going to look at levels, and whatever index we're at, that's what we're going to map. And we're going to specifically map it from a range. This is going to be the sound range. So negative 100 decibels to 12 decibels is, fairly standard on a thing. If you wanted to make it a little jump a little bit more, we could maybe go -60 to 12. Again, those are the decibel sound levels for each frequency. I'm not going to break down decibels right here. The next thing is what we want to actually map it to. So we want to have the lower end of the spectrum be the bottom of the screen. Well, that's just height. And we can set the higher one to be 0. So whenever the sound is at its maximum volume, the line will be at the top of the screen. And maybe we don't want it to go past the buttons or whatever, so maybe we'll make this 50 instead, just so we have a little bit of wiggle room at the top of the screen. So we have that there. Oh, Adobe's updating stuff. That's not going to be annoying. From there, we can set up some stuff. We can say... I'll come back to the colors. In my practice for this, I also made this as a little variable for this bin. A very that specific line. That's going to be, if I could type a line. Hold on. No, if you're not going to be in my video, go away. My cat wants a treat right now, and she's being very pushy. I told her I'd get her one after I was done with this. But she doesn't want to be in the video, and so you can't look at her. It's, cats. But anyways, we're making a line, and we're going to stick it at I, and I say I times 10. And I pulled that 10 from the weight of my stroke weight here. So I just make those match up, and then you don't have things overlapping as much. If you wanted to give them a little bit of space between each other, you could decrease it a little bit. We'll see what that looks like at I times 8. And then height is the bottom of the screen. I times 8 again for that X coordinate to make it a vertical line, and then we'll look at bin mapped, just like so, in order to do it. And at this point, we have a functional version. So just to break down what's happening is we've loaded up a sound file and we're going to play it. We're going to run it through the FFT and out to the speakers so we can hear it. We're going to trigger that with the buttons I have right here. Every frame, we're going to look at the levels coming in to that sound file, and then we are going to map that value to the range we need to see it on the screen, and then we'll display that as a line. So now if I save this and refresh it, and we start the code, we start the sound file, we should see lines appearing on the bottom. All right, I'll stop that right there. So you noticed a few things. One, all the lines are black by default, and it was mostly bunched up in this area down here. So that's what you're going to mostly find. Most sounds live in a specific frequency in terms of what we hear musically. So the human hearing spectrum has a lot more top end than a lot of instruments give us. You can adjust that by making less bins. So if I made this, instead of 128, if I did 64 and halved the number of bins, but if I made a whole lot more, and let's say I did the maximum at, what was that, at 16,384, because I'd never remember that, and start, refresh it and start it, we're now not getting anything because this is all the super bass. So let's just make this, we'll make it, I don't know, 1600 pixels wide on the canvas. And now if we start it, I'm going to stop that. It was, chugging along because it's having to cram through so many calculations very quickly. And also there's just a ton. So I like to break up my areas into, something a little bit more manageable. I found 128 gets the job done for most things. again, we're using a web browser to do this. We're not buying a dedicated piece of equipment. So again, it gives us an idea. You can play around, find exactly what you like. Okay, let's make it look a little bit nicer, though. One thing I like to do, and I think is kind of fun, is to have the color of the line change depending on what the level is. So basically, the higher the level, the more different the color goes. And we can do that by just talking to the stroke. I always forget the R. Whenever we're making the lines. So what we can do is just refer to the bin mapped value, and then I'll just give it some arbitrary values for the green and blue here, just to start with. And now, as I run this, you'll see that it's if I did this right, this will change between a kind of a, it'll get, a very light pink to a very dark purple as the sound levels increase. Let's change that back oh, let me put this at negative. Well, I'm putting it back to exactly what my test was because it's not actually changing colors very much. So the reason I changed that mapping was partly to match up with my test. And you'll see that, again, by changing the mapping, the sound levels got a lot bigger. So you could squish it down, depending on what you need. It may or may not work. I picked, negative 112, or in the case of negative 60, just going off of, standard audio mixers. I tend to see they'll tap out either at negative 60 or, in the case of some higher end ones, around negative 100. So that's where I picked that. So by changing those, but you can see as the more prominent levels of sounds pop out, the bar color changes. You can tweak this to be whatever you want color-wise. Maybe I want it to change the amount of blue instead. So I'll just... because right now, if I just did it, it would be... But if I put it here instead and refreshed it and maybe I want to include it for several of them. I don't know. This is where you can explore and play around with. So again, you can play around and find the exact settings for what you like and what you need, in order to create what you want to create. That's it in a nutshell. Another thing I sometimes see is adding a separate line that indicates whatever the highest value was. That can be a little more complicated because we have to save the values and update them all manually, and there's 128 of them right now, every frame. So that can become a little more complex, but if people really want to see that, put it in the comments and I'll hop to it in a future video. But just to illustrate something else, we could say just push pop, just so I don't overwrite anything and break it here. But we could just do a little line as well, only instead of that, we'll make it a horizontal line. So we'll put it at, let me think about this. I'm doing this part off the cuff completely. So we'll put it at bin map. I want to make it a black line, and a thin black line. Just so it's really simple to see what it is. We'll put it at that location. horizontally, we'll make it, how did I do that? I times 8 minus minus 3. Why not? And then I'm going to copy and paste all of this. Place that with a comma and change that to a plus. So what I've done here is essentially make a horizontal line that will follow the top of each bin, and it'll just kind of be centered on the location of that bin. And there should be just a little bit of space between them. So if we start this, I got that backwards, I guess, but that looked kind of I wasn't expecting that. I got these flipped, so we're just gonna swap these around just like that. Copy, paste, bin mapped, and bin mapped. Okay, let's try that again. So this sound file is pretty constant throughout in terms of volume, but the idea for the final functional version is that line would kind of stay there until a new one passed it, and then it would go on a peak meter, essentially. That's a little bit more difficult to do, so I'm not going to do it in this video that's already been going on for 30 minutes. But again, that's the end of this one. Again, what we've done is from the ground up, loaded in a sound file, and given it a button to start and stop it. And then we are creating some dynamically changing graphics here in order to represent each a section of the sound spectrum that we can hear and indicate its level with the height of the line. This is a fairly standard thing to see in a lot of musical applications. We don't always see it in a web browser scenario like this. If you had a physical piece of hardware or another piece of software that wasn't browser based, it'd be real easy just to hook up the input audio jack and plug something in, or say, hey, connect to your microphone, do that. Because of a lot of the regulations with web browsers and accessing people's microphones and cameras and things of that nature, it becomes a lot more difficult in this situation in order to do that. If I can work out a good way to do that and record it, I'll make a follow-up video as well. How to do that. But for right now, you can make any audio file. You could record, make a thing with the tone.recorder object. I've made a whole video about that as well, and use those files and all of that. But again, I'm not expecting this to be something you might use in an everyday situation, but it's just kind of a fun thing to think about, that we're breaking up the sound spectrum into different sections. We're looking at each of them individually, and we're using that data to make something visual on the screen. So that's where I'm going to end it out today, I think. I'm going to change this color just to see what happens. I'll make it closer to 100. But that's where I'm going to end it out. We're just going to listen to the loop on a little bit of outro. And we'll see you all the next time that I see you. Bye. There's the whole file. All right. Like I said, I'll see you all the next time that I see you all. Bye.